Assalamu alaikum everyone. Hope that you guys are doing well, inshallah. Um, we're going to begin learning online. So the first lesson that we're going to cover, or more like complete, is lesson number 31, right? So that's basically what this video is primarily about. However, before we do that though, let's just take a quick peek at the agenda. Number one, the whole concept of learning online is not new. It's been around for actually quite a while. Even I remember when I went to college 15, 16 years ago, my professors used to post videos of their lectures online. It's a brilliant way of learning. For many of us, it's actually a better way of learning. And so I hope that inshallah you benefit from these videos. And the best part is you can forward and you can pause and stuff like that as you go through them. All right. Besides that, everything else, as far as the online tests and the quizzes and stuff like that is concerned, it's all the same. All right. There's not going to be much difference. You're still going to be graded. I will be doing all those same things as I used to, inshallah. The tests are obviously going to be created in a certain way to reflect the fact that it's not a 45-minute thing anymore. It's not something that's timed anymore. So I had a question from somebody about this. So yes, the online tests and the quizzes will be slightly different in their formatting. But in general, they're still asking essentially the same stuff that you would have had to answer in class. All right. Really quickly, my office hours are from 8 a.m. to 10 a.m. and 12 p.m. to 2 p.m. It's just something that Salam School told us that we have to tell students. Of course, if you have any questions, I am always available. And quite honestly, we're not even going anywhere much these days. So, you have an email, you don't understand something, I'm always here to support you, and you know that, inshallah. All right. Number 4, again, any questions that you have about homework and whatnot, generally I will be posting all the solutions to the homework, or at least selected questions from the homework. I will post those solutions. But if there's still something that you don't get, feel free to just comment online underneath that homework link, and it'll be a benefit for everybody. Don't feel shy or anything like that. It's going to bring us all out of our comfort zone a little bit, including myself. But inshallah, we'll get through this as a class. As you would have asked the question in class, just ask it online as well. All right. Number 5, we will be completing lesson number 31 today, as I mentioned earlier. All right. And we're going to go ahead and get started, inshallah, with this lesson. So the first thing that I want to share with you about this lesson is where we pick up with this. Bismillah. Okay. So recall in lesson number 31, we had completed going over graphs of sines, cosines, and tangents. And cosines. But we had only done, I believe, one question possibly on tangents. So I'm just going to quickly teach you how a graph of a tangent function looks like, and then you guys will have these 3 questions as your homework assignment, inshallah. All right? All right, and the important concepts sheet, that basically the reason why I put that little link there for you is to remind you that there is a very nice section that I made for trigonometry, right? It's all the way down in the pages because we are coming to the end of this course here. So I made this page for you, if you recall. And what I want to share with you is the page that comes after that is also very helpful. It says graphing trig functions and transformations. So this is a nice little review sheet for lesson 31. And it tells you about what a sine graph looks like, what a cosine graph looks like, and a tan graph looks like. So I shared this with you. This should be in your notebook already. but this is what a tan graph looks like. All right, and it tells you how to be working with the transformations and things like that. All right, so it's very useful, it's very resourceful, it's really helpful, and I'll leave this out there for you. And I might even reference it during this lecture, inshallah. All right, so I don't want to make these videos that long, but you know, they tend to kind of stretch because I talk so slow. But inshallah, let's get started. So the whole objective of this is to basically graph a function, all right? And the questions that I have chosen to give you as homework are 17, 21, and 33. All right, so let's just take a look at that. 17, 21, and 33, which is, I believe, on a separate section. All right, so let's just take a look at number 33. It might be asking you to create an equation or possibly so number 33 looks like that right there, right? Y equals 10, 1/4 x plus 1. So I'm just going to take one of these questions here, inshallah, and or we'll make something up as we go along with it. So let's take number 22, all right? Number 22. And in number 22, it says y is equal to tan 1/2 x. All right. Let me add a little bit more to that. Let me put a subtract 1 out here, and let me put the number bismillah 1/2 out here. Okay. All right, so this is my example, and it's the only one that I'm really going to do. So it's not really number 22, it's just an example. It's just an example that I'm making up based on number 22. All right. Now, let's get started. The first thing that you want to do is you want to quickly make a table, and I showed you guys how to make a table for tans in class. It should be in your notebook, but again, if you don't have it, and if you don't know where to find it, here's a really nice place to find it right here. All right, so that's the tan table. All right. Let's go ahead and try it. So we have negative pi over 2, and tan at negative pi over 2 has a vertical asymptote. Then we have negative pi over 4, and tan at negative pi over 4 is negative 1. We have 0, and the tan of 0 is 0. All right, now let's move on to the next one. We have pi over 4. All right, we have pi over 4, and the tan at pi over 4 is a positive 1. And finally, we have the tan at pi over 2, which is once again equal to a vertical asymptote. And remember, it's undefined there, basically, is the logic behind that. Okay? All right, now, what we're going to do is we're going to transform this table. All right, we're going to transform this table. So here's how you do that. First, you got to figure out what's the value of A. The A in this situation is 1/2. What's the value of B? The value of B in this situation is also 1/2. And the value of D is negative 1. There is a C, but this year we have left C out. It's okay, you won't get hurt much by not knowing it. All right, now, this is supposed to be divided by B, again, because B is 1/2. What that really means is we're going to be dividing everything in this row by 1/2. All right, let me just take a moment and turn off this mode because it keeps switching. All right, then the bottom one is you're supposed to multiply by A, and you're supposed to add D. Okay, now remember, if D is a negative number, then that what means is that you're really subtracting 1. So what this means is we're going to be multiplying all of the Y values by 1/2, and we're going to be adding, so we're going to subtract 1 from it. So that's the instructions for you as to how we're going to go about this process, inshallah. So here is our transformed, here is our transform table. All right. In our transform table, essentially what you can do is you can just leave that as an X, but the bottom, if you don't have space to write in that entire equation, so the entire equation is all this, so you just put a Y there to compensate for that. You just say it's a Y, okay? All right, so now let's go ahead and begin by dividing each of the X values by 1/2, all right? So when we divide negative pi over 2, right, by 1/2, realize what that really means is negative pi over 2 multiplied by 2. And so these 2's cancel out, and what we really have here is a negative pi. All right? So let's just kind of keep moving with that same exact idea. This is going to become a negative pi over 2 then. This one right here, 0 divided by 1/2 is still 0, so that does not change. The next X value, pi over 4 divided by 1/2, is going to give you a positive pi. And, it's going to give you a pi over 2. Okay, so pi over 4 divided by 1/2 gives you pi over 2. And finally, pi over 2 divided by 1 over 2 is going to give you a positive pi like this. All right. Now, as far as the Y values are concerned, this right here says vertical asymptote. If you guys just think about it, a vertical asymptote, you can't add or subtract any numbers to it. That just doesn't happen, right? So a vertical asymptote will remain a vertical asymptote. That's not going to change, okay? So both of those remain exactly the same. All right, the next thing that we're going to do is we're going to multiply each of the Y values by 1/2, and then whatever we get from that, we will subtract a 1. All right, so let's go ahead and start. There's only 3 Y values to be working with. So the first Y value is a negative 1. If we take a negative 1 and we multiply it by 1/2, we get negative 1/2. And if we subtract 1 from that, we get, bismillah, negative 1.5, right? So I'm going to go ahead and write down negative 1.5 like that, all right? The next one is 0. When I take 0 and multiply it by 1/2, I get 0. If I subtract 1, I end up with negative 1 like this. And finally, 1 times 1/2 is 1/2, and 1/2 minus 1 gives you negative 1/2, or negative 0.5. Okay, so there you go. Those are our new values, and the last thing that you essentially need to do is just make a graph of what you're looking at. That's it. All right, so I'm going to make a quick sketch here. All right, so here's my sketch. Remember, it's supposed to be longer in the Y's than in the X's, like this over here. And I am not going to put the original values in this graph. I'm just going to go ahead and put in the transformed values. And the reason why is because you guys know how transformations work because of sine and cosine graphs. You know that the original graph, there's things happening to it from here to here, all right? Now, the first value that I need is negative pi, so I'm going to go ahead and put a negative pi. And the last value that I need is a positive pi, so like this, all right? Furthermore, now what we're going to do is we're going to fill in the rest of the values. I need a negative pi over 2, and I need a positive pi over 2, and I need, of course, the origin, which is a 0, all right? Next, it looks like all the values are essentially traveling between negative 1.5 to negative 1/2. So I'm going to go ahead and take some space here. I'll exaggerate it a little bit. Let's call this negative 0.5. Let's call this over here as negative 1. And let's call this negative 1.5. So what I'm going to do here, looking at this graph, all right, looking at this graph, what I'm going to do here is I'm going to just kind of extend Bismillah, I'm going to extend this y-axis a little bit so you guys are able to see what's happening with that graph like this. All right? Now, let's go ahead and make those values. It says at negative pi, you're supposed to have a vertical asymptote. So I'm going to go to negative pi, and I will simply sketch a vertical asymptote there, as I have over here. Okay, so there you go. Then the same thing happens at pi. So while we're making those vertical asymptotes, all right, we're going to go ahead and go to pi, and we will also make a vertical asymptote there. That's just the quality of the tan graph. All right. Now, the next value that we're going to jot down is negative pi over 2, comma negative 1.5. So that would be right about here. Then 0 comma negative 1, that's over here, and then pi over 2 comma 0.5, that's over here. And the last thing that you got to do is do a neat job of connecting these dots, not as Bismillah, not as lines, but like this over here. Okay, so there needs to be a bit of a curvature as it travels. There's not an exact line, and of course it can't go past the vertical asymptote, so you just draw an arrow going down like this. And so that is the transform table. Last few things that I'll mention about this is a tan graph, right? A tan graph, its period is not 2 pi over b. All right, it's not 2 pi over b. That was for sine graphs, and that was for cosine graphs. Both of their periods were 2 pi. All right, so that used to be the period of a sine or a cosine graph. And what that means is it used to take, if it was a sine graph, it used to take an entire 2 pi from 0 to 2 pi for it to complete its cycle. And if it was a cosine graph, it would still take from 0 to 2 pi to complete its cycle. All right? So that was the period length of sine and cosine. The period length of tan, right? If you think about it, if you look up here, the period length of tan, if you start from negative pi over 2 and you go to pi over 2, let's take a look at an original graph, right? It's very handy right here. Let's take a look at an original graph, Bismillah. All right. So if you take a look at this right here, notice how from negative pi over 2 to pi over 2, that's essentially the tan graph, right? And so what we're really trying to imply is it does not take a period of 2 pi to complete a tan, or then for that respect a cotan graph. It only takes 180 degrees, or basically pi radians, from here to here. If you count up negative 90 degrees, positive 90 degrees, that's actually only 180 degrees. So one of the qualities of a tan graph is its period from beginning until end, how long it takes to finish, is actually just going to be a pi. Okay? Now if you're looking at this and going like, wait a minute, how is that pi? Because over here I see a pi over 2. How is that a pi? Again, you have to think about the fact that there is 90 degrees here, and there's another 90 degrees here. That's why it turns into pi, right? So the sine and the cosine graphs used to start from the origin, all right? They used to start from either y is equal to 0 or y is equal to 1, and x is equal to 0 in both of them. But for the tan graph, it doesn't start from there. It actually starts from before the x-axis, and that's what makes it that way, inshallah. Okay, I will be posting a homework for this, and all the further instructions about it will be online. So good luck in completing that homework, and inshallah, eventually I will also post the answers to one of those questions from the homework as well. Jazakallah khairan for listening. and Assalamu alaikum.